This is a quick video just going over a mechanical wave model. Now the one that we ultimately came up with or come up with in class may be slightly different from this, but it's going to all revolve around the same central ideas. So let's jump into it. A mechanical wave model defines a wave, and a wave is a phenomenon where four statements are true. Energy is added to a medium, and then energy is transferred from one place to another within the medium. As a result of the wave transferring through the medium, there is no net displacement of the medium, and the medium resets itself. Now, because it's a mechanical wave, that means that it's a physical medium. And we'll talk later about other waves, electromagnetic waves, which don't have a physical medium. But for mechanical waves, we're talking about physical medium, which just means it's matter. It's stuff that you can touch, in a sense. So that could include air, that could include water, that could include a slinky, that could include all sorts of things. But just kind of going through these statements and giving a little more context to them. Energy is added to a medium. This means a wave doesn't just pop out of nowhere. A wave is generated or created by adding energy into a medium. The main one that we're going to kind of tend to think about is this one right here. Like if you see what you call a wave, what you're probably seeing is that transfer of energy. There's some sort of disturbance or change in the medium that's going to move from one place to another. There's no net displacement of the medium or in the medium. This just means that the stuff itself doesn't really move from one place to another. It's not like a car traveling down the road. That wouldn't be considered a wave because the car itself is moving. But for example, the pulse traveling through the slinky, that compression's traveling back and forth, the whole medium, the whole slinky, the whole spring is not moving from one place to another. It's just this kind of, disturbance in the slinky is moving from one place to another. And then the medium resets itself. There's nothing from the outside that's causing it to reset or to go back to where it started. It's doing it kind of automatically because of the kind of internal forces of the medium. So examples from the lab, we have basically both slinkies. Or if you want to call them springs. So the spring compression and the spring pluck would be our first two. And then the third one was the water with the ball. And these are the ones that are pretty clearly defined as waves. There is a wave going through the water. You pushed up and down at one point in the water, and the ball moved up and down as a response because that up and down energy motion moved from one place to the other in the water, and you weren't resetting that. You weren't causing that water to go back to how it was. So that's the real quick example of the mechanical wave model. Again, the four statements here apply to all waves, but what we're looking at with kind of the first part of this unit is for physical waves. That's what we mean when we're talking about mechanical waves.